whatever your data is for activity A number 6, make a graph. Or if you want, you can use the exact numbers I have here so your graph looks just like mine. It's your choice. So first off, X is the time. So we have 0. Oh my goodness, preferences. Sorry, you should probably do this too. Afterwards, enter should go down. Okay. And then 10, 20, 30, 40, 50. And this is time, t seconds. And this is the number of radioactive atoms. Do that n, and there's no actual units for this. And the reason we did 5 trials was to find the average. So we're going to use the average here. 128, 62, 29, 13, 6, 2.6. It gives us a wonderful graph that looks like this. There are various things we should choose. The best one, which hopefully works beautifully, is natural exponent. Gorgeous, because it really is this in real life. If you do grade 11 physics. Okay, and we have our graph. Now what you need to do is double click the graph. We click axis options. Oops, sorry, graph options. And we have to turn on interpolate. I'll tell you why in a second. If we choose this button, where's the examine button? Tangent, examine button. Basically it jumps from point to point. It tells us at 10 seconds is this, and it only jumps from the actual data points, but we want to actually read the graph. In order to read the graph, we need to turn on interpolate, which means to look within the data. And now when we do this, it tells us quite precisely. And we know the half of 128, well, is 64. So when we get close, I can actually use the arrow keys to get as close to 64.0 as possible. Right there, it's pretty good. And here we get a time of 9.4 seconds, which is pretty close to 10 seconds. Okay. And again, this is not the perfect graph. This is real life data. Okay, and this is how we get the half-life. And this is the same thing that you're going to be doing later in your homework and next week in your lab test. You get some data, you make this graph, you find the half-life. It's pretty nice and simple. Good luck, and any questions, please ask.